Hello students and family members, this is Mr. Panza. It's time for our division test. So tonight for homework we have this review sheet. First things first, make sure your name is at the top and on the left hand side, because most of the problems are going to revolve around the step-by-step process of division, please write D, M, S, B, and R for divide, multiply, subtract, bring down, repeat, or remainder. That way, when you get a problem like 65 divided by 3, and I ask you to show all of your work, you can show me that, yes, if I have 3, I'm dividing these 6 pieces, not the full 65. Don't overwhelm yourself. And 3 can go into 6 twice. That's division. Because the second step, multiplication, says 3 times 2 is 6. And because that 6 is in the tens, it's worth 60. Now subtract. The step-by-step process I'm following is right over here.
Mrs. Novak, please call extension 6000.
Sorry about that interruption. Now that we've subtracted, we bring down our divisor. And if this number is lower than 3, and we had filled in all of our place values up here in the quotient, we're done. Well, in this case, the number is greater than 3, and we can still fill in a spot here into the ones category. So how many times can 3 go into 5 is restarting the process at division again. Can go in 1 time. 3 times 1 is 3. Subtract and get your remainder of 2. Because you have filled in all of the place values, the tens and the ones, and this 2 is less than my divisor of 3. My final answer, 21. Remainder 2. If you'd like to check your answer, you can check with multiplication. First, do 21 times 3. Repeatedly add 21 plus 21 plus 21 is going to get you 63. And then add your remainder to see if you get the dividend that you started with, which was 65. And since I've multiplied my divisor and my quotient, added my remainder, and got 65, that means my answer to the division question, 21 remainder 2, is correct. The second problem is a 4-digit dividend by a 1-digit divisor. First things first, can you divide into this 6 before you divide into 63? Absolutely. 1 time. Multiply. 6 times 1 is 6. Because it's in the thousands, it's worth 6,000. Subtract. 0 minus 0, 3 minus 3, 3 minus 3. Bring down my divisor of 6. And now I see, can this 6 go into 3? It can't, but I cannot leave this hundreds place value blank. So I have to fill it with a 0, subtract everything again, which will get me 330 again. Because 6 times 0 is 0. And when I subtract, I'm going to get 330 and bring down my 6. Now I can divide into 33. 6, 12, 18, 24, 30. I stop there. If I got to 36, I gave away too many. So in this case, 5 times 6 is 30, which is 300, which leaves me with my final piece, the 0 here, and 6 into 0 is 0. And my answer is 1,050. Don't be fooled by them saying 6 being subtracted from 6,330. I do not want you to repeatedly subtract. It's just to show you that division is repeated subtraction. Fact families, you know how to do these. 2 multiplication fact families using the commutative property, and 2 division fact families to make sure that you understand how things can go. The other more difficult problems will be the word problems, and we taught the students 2 strategies. A KWS chart, what do you know? What do you want to know? How many trains Michelle has, and how can you solve it? A multiplication, or in this case, division number sentence that will help you solve. So, first I need to type in what I know. And the second strategy is use a bar model that looks like the one I've drawn here. What do I know? Michael and Michael's brother have a certain amount of trains. Michael has 2 times as many as his brother, although the word problem states it differently. It says his brother has half as much as he has, which is just represented by this bar here, cut in half. And we know that if we add these 3 bars together, or multiply them together, we get a total of 144 trains. So in this case, the total number of bars, 1, 2, 3, become my divisor. There are 3 separate bars or 3 separate pieces that I am dividing the 144 trains by. This is what I want you to try by yourself. Divide the 144 by 3, and whatever your quotient is, the answer to that division problem, you fill in these bars. But then go back to the W. Remember that you just want to add these 2 bars at the end to see how many Michael has. Once you've done that, flip it to the back and try another one. Number 8 is a simple division question, just stated in a different way. How many groups of 6 can you make out of 42? If 6 is the total number of people and 42 is my dividend, can I group it that way? Yes, that's what dividing is. So divide 42 by 6. Number 9, a 3-digit dividend by a 1-digit divisor. The only hint I'll give you here, make sure that you are dividing first into the 59. 7, 14, 21, 28, 35, 42, 49, 56. And that 8, those 8 tally marks that I have over here, goes above the 9 because I've divided into the 59. Then you multiply 7 times 8 and your answer goes here, and that's when you subtract. But down to the more difficult question. Again, I have a word problem in which a KWS chart is going to help me solve. K is what I know, the information from the problem. The W is the question, what I want to know. And the S is how I solve it using a division number sentence. Let me set it up for you. I have a baker. Her name is Kara. If I look at Kara's cupcakes, I have a total amount of 476 muffins that are being divided equally by a certain amount. And in this problem, what you also know is that amount. They tell you that she will put the cupcakes, or in this case the muffins, in cartons of 4. So I need to take the total bar and separate it into 1, 2, 3, 4 pieces. And like I told you on the previous one, this is my divisor, and over here my total number is my dividend. So set up a division problem and solve. 476 muffins divided by the 4 cartons. Divide, multiply, subtract, bring down, repeat, or remainder. Whatever you get as your quotient goes into each individual bar, and then you answer the question, how many cartons did the baker use? I hope this helped you set up most of your math homework tonight, and it gave you a little bit of review for tomorrow's test. Have a good night.